Okay, can you see my screen right now?
Yeah.
Okay. Oh, I'm sorry.
Thank you.
This should be the last one. Okay. First of all, thank you for invitation to present here. Really a pleasure to talk about our work. So I'm going to present this scoping review. We worked with a team of people. So let's start from the background. In the cancer domain, we know that it's a very lethal disease, and we need robust frameworks, especially for observational research. So OHDSI network provides a common data model. Basically, we know that there is a same protocol that can be used for multiple individual sites. At each site, we can use standardized terminology to normalize the data. And in this way, federated analysis can be done. So this is a super methods that can be used for multi-center studies, while in the same time, patients' privacy can be conserved. So at the same time, there are many other similar type of networks, but our study only focused on OMOP CDM common data models. There have been some related review studies that focus on OMOP's potential in cancer domain, but at the time of this scoping review, the breadth of the adoption in cancer is not well understood. So our goal in this scoping review is to analyze the status, challenges, and opportunities of OMOP CDM in cancer research. The time frame for the study includes from 2010 to 2023. We use several popular databases in the biomedical domain. This figure shows all the process, how we do the paper identification, screening, and selection. So at last, we included 49 articles for scoping review. How we did chart review, how we extract the data elements and classify all the results. In the beginning, we classify all the papers into two main themes, including data analysis and infrastructure. So we found that even we use a keyword of, OHDSI OMOP for paper retrieval, not all papers are focusing on only observational studies. It also includes articles that utilize the advanced analytics, including machine learning or NLP methods. So we include this part of a study as the data analysis theme. At the same time, for OHDSI OMOP, infrastructure is another major category. So this category of papers describe the reusable tools and practices for transforming data into the OMOP CDM format and expanding them to support additional data types, especially in our this study scope is for cancer domain. For data analysis theme, we extracted the data elements following the STROP checklist. We follow this all the data elements defined in the STROP to identify important critical data elements from papers. The relevant elements, especially the clinical event, this type of elements we further aggregate based on table names in OHDSI CDM version 5.4. The infrastructure was categorized according to the OMOP construction process, including data normalization, linkage, transformation, how to do the model expansion, etc. So the relevant data elements were extracted also and aggregated based on the version 5.4 0.4 when that is available. So this table shows how we do the relevant data element mapping from the paper to the target CDM tables. So we see, for example, for diagnosis, condition, or medical history, if they are mentioned in the paper, we map this to the condition occurrence. And also the other clinical events also mapped accordingly. This figure shows the metadata analysis for all included papers. So eventually there are 30 papers for data analysis theme and 20 papers for infrastructure theme, because there's one paper talking about both data analysis and infrastructure. So we have here 30, 20. The first, you see here, the A, table A, figure A here shows the trend of the publication over years. We can observe increasing trend. You see from 2017 to around 2022. And some key milestones can be identified. Even we included a paper from 2010, we found the first in-depth data analysis paper published in 2017, and the first infrastructure paper published in 2018, talking about how to build individual OMOP infrastructure for cancer. And in 2020, this year is the start of global collaborative studies. Global study means a study spanning over at least two countries. So this figure B shows the data sources for two study themes. We can observe that EHR is a major data source, but claims is also another important data source. Besides these two data sources, there are multiple other data sources. So the data sources for OMOP is beyond EHR and the claims data. Let's move to C, the geographic regions for the papers span to three major areas: North America, Europe, and Asia. The last figure actually shows types of cancer. We observe that a lot of common seen cancer types are included, like breast cancer, colorectal cancer, but some rare cancer types are not well represented. For example, in our included study, we have only see pancreatic cancer, pediatric brain cancers. These are rare cancer types, but they are very limited in including rare cancers. This table shows a very clear view of the data sources. So we mentioned the data sources is beyond only EHR and claims. We can see there's only not only EHR claims, but also information systems for research, for data analysis part, government data sharing initiatives for both study themes, survey for data analysis, and then the remaining data sources are exclusively for infrastructure themes. These are the ongoing efforts to build the data infrastructure. So we can see the focus is on more clinical registry, omics, biobank, public knowledge base. So it's expanding beyond EHR claims data. So this figure shows a comparison of the clusters based on article numbers and of co-occurrence of cancer type and the CDM tables. So we mentioned that when we extract data, especially clinical events, we mapped this event to CDM table names so that we can have a clear comparison between the two themes. Figure A shows the infrastructure results. B is for data analysis. We can see the data types are different between the two SIEMs, and also the CDM tables are very different. The B is the data analysis. You can see that data analysis SIEMs covers commonly they are using the eight tables: condition, death, drug exposure, measurement, observation, person, procedure, visit, occurrence. So these are mostly used tables for data analysis. Data analysis theme. Data analysis themes include um, observational study. It also includes advanced analytics, including machine learning and natural language processing. So this is a major difference between the utilization of the CDM tables. So we can look closely for the infrastructure table. What's more than the data infrastructure in the tables? So we can see that care site, cohort, device exposure, episode event, factor relationship, genomic imaging, location, note NLP, um, so specimen, target, variant, vocabulary extension. These are the additional tables focused by infrastructure theme. And if we look closely, you can see, for example, for node NLP table, this study is focusing on the colorectal cancer type. For example, for visit occurrence, not vocabulary extension. This is for unspecified cancer type. So we have unspecified cancer types for the papers. If they did not specify specific cancer types, we label that table that paper as unspecified for the cancer type. So we will observe this difference for specifically CDM tables. What about infrastructure theme? Let's go to the table. This table shows the subcategories of infrastructure, including 4 main categories: infrastructure development, transformation of various source data types to OMOP CDM, data model extensions, development, and data linkage and standardization. We see different numbers of paper fall into these 4 subcategories. And a close look at the specific geographic regions for infrastructure theme. We see that studies were split relatively equally across 3 geographic regions, including US, Europe, and Asia. Asia includes South Korea and China. Within Europe, Germany was particularly distinct as it contributed 5 of the included studies. So we see the geographic regions here and the source data sets. Most of the studies, 11 out of 20 studies, they used only one single data set for infrastructure construction, which is reasonable for infrastructure efforts. And we also see multiple data sets were utilized for infrastructure construction for within different numbers of studies. What about CDM extension and data enrichment? There are 7 papers talking about this topic, and we see the distribution of the studies on oncology-related data elements, omics data, imaging data, and evaluation of the mapping quality. We take a close look at this mapping quality evaluation because this is very important factor for the construction of infrastructure. The results show that major point is non-papers in this category did not report a direct evaluation of the mapping quality to OMOP CDM. So basically, the evaluation metrics were not well defined. So we do observe some evaluations, like the mapping coverage percentage of the source rows that were successfully mapped to OMOP CDM standards, or the proportion of clinical concepts that could be successfully represented in the standard. There are two studies did not include evaluation, but did report of a metric of percentage of concepts that were not represented in the tables. Data mapping limitations. Results show that the OMOP CDM could not represent certain clinically relevant concepts without further extension, and some data were not directly available in structured form and require algorithmic normalization. So let's go to the data analysis theme. This figure shows a linkage between different area topics for data analysis paper. So we defined aggregated cancer type to system level when feasible, and geographic areas, and study cohort size. That means what's the size of the study cohort using OMOP CDM? What's the start year of the study? What's the study period? The span of the study period, how long the study period lasts. So we can see that in the aggregated cancer type and geographic areas, we for this column, for the cancer types, there are digestive, gentle, unitary, unspecified, endocrine, respiratory, nervous, head and neck, skin. So these are different aggregate cancer types. We see over all the 30 studies, 50% of the studies leverage the multi-site data sets, ranging from 2 to 11 individual sites. There are 15 studies on the South Korea population. You see here geographic area. They covered all cancer types except nervous systems, which was exclusively conducted in the US population. We also observed 6 local studies in the USA concentrated on genital, urinary, nervous, and respiratory cancers. And Denmark and China focused on digestive system cancers in their local studies. So for the cohort size, we see a large-scale capability enabled by OMOP CDM, over 1 million patients, and the study period over 15 years. We also see the early study data sets start in 1986. So as we observe that 15 studies, that is 50% of all the study came from Korea. We did an ablation study removing Korea. So this figure shows the results after removing Korea. We see here after removing Korea, the study period from 1995 to 1999 were also removed, and the 3 cancer types disappeared, including endocrine, head and neck, and skin cancer types. These were dropped out. This figure shows analysis specifically for institution level analysis. So we compare with the OHDSI collaborators on the website, and calculate the numbers of the mapped and unmatched institutions. So we see the institution names in the two tables. In the data analysis SIM, we also look at the target domain of study designs, analysis methods, and also CDM domain names for the study. So we can see there are diverse research questions shown as a target domain of the study, including disease, drug, cancer association, other domains, and study designs including predictive modeling, cohort study, other design descriptive study, etc. For the specific disease domain, we look at the research questions. These are the typical research questions in the disease domain. For example, disease characteristics in cancer patients, cancer risk analysis, other disease risk analysis in cancer patients, cancer case prediction, perioperative disease analysis in cancer patients, and also survival analysis prediction. So this is the summary of papers adopting NLP. So during our scoping review, we found that NLP was only used in, you see here, there in 4 papers. One is from the data analysis, advanced analysis SIM. 3 was from infrastructure SIMs here. So we do see some challenges using NLP for standardizing data elements into OMOP CDM data. So there is an unstructured gap. Especially in the cancer domain, a lot of relevant information actually are in unstructured text data like pathology reports, but very few studies is currently using NLP-derived data elements. I think that is the contents from the scoping review, and Hongfang will go next.
Sure. So this, as you can see, the OMOP CDM in cancer domain, we didn't see humongous amount of studies, based on OMOP OHDSI framework. So let's move on to the next slide. So our research team originally primarily focused on open house natural language processing, which is to try to release a set of tools, NLP algorithms, information extraction, algorithm for cancer phenotyping. So this scope review actually was conducted prior to the OMOP OHDSI CDMs, because our original interest more related to what other cancer data elements are embedded in unstructured data. And it is to try to see where are the gaps, how do we, from the natural language processing side, help advance cancer research. So in this specific scope review, also led by Liwei before, is to try to assess the use of EHR for cancer research and patient care, and through the analysis of cancer NLP. Go to the next slide. So this is just showing you the results. We noticed significant number of data elements, such as breast cancer. There are a lot of documents were used to extract the data elements for those studies. In pathology reports, we noticed for prostate, they heavily involved into getting cancer staging, cancer diagnosis related information. and clinical notes, radiology reports, and all those are popular document types. We see number of critical cancer study data elements. They are embedded in those unstructured data, which is means that if a researcher wants to have a good coverage of those data elements, they actually need to do natural language processing to extract information from those reports. Next slide. And this specific scope review also try to evaluate the M-code, which is the minimum common oncology data elements M-code initiative, launched in 2018 by the SCO, MITRE, and other funding collaborators. The M code or was designed actually try to say if you want to leverage oncology practice data for studies, those data elements are critical, need to be captured. When we study the distribution of the NLP extract data elements covered by M code, this is just illustrating a significant amount of data critical for cancer care and cancer studies are embedded in clinical text. In this diagram, you can see 84 papers were specifically, using the text notes, using NLP to extract disease-related information. About 37 is the primary cancer condition that we're using that. Think about the cohort identification. Think about those things when the primary cancer condition require researchers to get from the unstructured data. So there is, to us, is a significant gap in leveraging structured EHR data to do study without using the NLP algorithm for extracting those data. Next slide. So this is, we also evaluate M code and try to see what are the gaps of M code as minimum common data elements. What's the gap between that and the cancer research? M code recall before we describe is a lot of times is for oncology practice, and here we notice that in the application areas of cancer screening, social determinant of health, and a family history and some genetic testing, those information, those data elements not captured in code. It is reasonable for the cancer screening because a lot of data elements here will more relate to cancer, prior to cancer for preventing related issues. And the oncology practice, like M-code, they didn't have that. When we talk to the M-code teams, they basically say they count on the general domain to cover those data elements, specifically the fire domain related to those conditions. Next. And additionally, we also try to evaluate how those NLP data elements extracted. When they extracted, do they normalize to standard terminology? And if they normalize to standard terminology, what are the relationship between that to the M code referent standards? So here you probably notice that we notice a lot of oncology data elements extracted used to standardize NLP results. This is showing on the left. Then the M code, their target standard terminology is showing on the right. They're not common only three are showing as common between those two, but you notice in the review articles you have a lot not there. Next slide. So this is the classroom visualization of the M-code profiles and terminology used for NLP output. As mentioned, for the M-code profile, if you are not familiar with M-code, you can go search. Is one of the FHIR. It's currently available from HL7 FHIR standards. So primary cancer condition, secondary cancer condition, those are there are significant amount of oncology data elements was used for the NLP results, and then you go right, you see those distributions. Want to see the first row, which called none, means specifically those are not specified their target standard vocabularies used. Next slide. So, I mean, together you probably see all those two articles. We try to see for the use of real world data, what are the opportunities, gaps, and how critical, it is to really leveraging the unstructured data to derive critical data elements needed for cancer research. And we see, there are high potential for, especially for rare cancer or for drug repurposing, disease trajectory discovery. There are huge opportunities here. The newest cancer OMOP studies, you can see, even though there are not a lot, 50% of those probably single sites, but we do see huge advantage of leveraging OMOP CDM for multi-sites, multi-data sets, pooling together for studies. Our team is, promoting a federated NLP framework, trying to ensure the critical data elements needed for cancer research, cancer real-world evidence generation, leveraging the unstructured data. We have some general guideline how to do that. And mapping quality, it is something really require us to look at it, how to facilitating and share the mapping for standardizing or normalizing your data sets to OMOP CDMs. And one potential opportunity is that we do need collaborating institutions to really share how they do mappings, and those can help truly have avoiding potential buyers to and make the scientific discovery leveraging real world to be trustworthy. I think that's all we share here.
Yes. This is acknowledgements. Yeah. And
yeah, any questions for us?
Can I start? So thank you so much for your work. Like, I think people sometimes think that, all the standards and the mappings and everything are solved problem or easier. And I think, the more depth we get into the data, the more we realize that there's lots of work to do. And I think your study was really useful to show that. At the very end there, you were talking about things that like could move the field forward. How do you think that the most practical things and most useful things would be in the shorter term, like, and maybe even in the longer term of those things? What do you think is the physical thing that we would create that would be a shift in how we move this forward?
Yeah, that's a very good question. We have been thinking about this a lot. In general, standardization always coming after the field being innovated in that. In cancer research, we know the data elements we study the concepts we look at it, probably a lot of times they are not structured well because it's an innovative idea, it's universal questions. That's the reason you do research on it because the field is not well known about that. So given that, we're actually thinking it is a loop. We needed to study, through those kind of review studies to see what are the gaps. Secondly, we always assume is that it needed to be proactive in the data connection phase. We know we cannot influence, for example, after the data be generated, if the data not standardized, not normalized, we need to use a P or use mapping, use these things to improve that. But what happened if at the beginning when people generate the data and those are standardized? So I really, consider the work done by MCode to be in HL7 try to push the standardization to the frontline data capture, the cancer care, oncology care side. So that standardization at the beginning can generate more high quality data. But at the same time, we of course cannot abandon a lot of data which are connected before. But those data connected before, we can use NLP, use mapping, use those informatics approach to help us identify gaps, so we can continue improve standards and improve data capture. And so this is iterative learning loops to us.
I should probably mention that within Europe, there's a different, so there's the European MCode group. It's called the it's the ECCM. It's a different group. They met actually on Wednesday, but we could have Roberto, if people are interested, if you want to like put up reactions, I can have Roberto come on to this call and give maybe a seminar in a month or two about how that's progressing, because we've been involved in that working group. If people would actually be interested to know about the European cancer model. Like it is very much like it's a model. So anytime you have a model, it's not everything, it's a subset of data. And I think, your insights here on the fact that like some terms are missing probably reflects the fact that any of these models are just a subset of data. And I think when we're seeing, so we run a project called the Health Hub for Cancer, and so that's largely one of the big projects, and that is connecting blood cancer data across hospitals. And one of the things we see there is that some of the elements needed for blood cancers aren't actually in a lot of these standard models, because we say for CLL, you want to know about infections. Infections aren't captured within cancer models. So then you kind of need two data models. So anytime we're dealing with models, I always think no model will fit everybody. It's kind of like the Cox thing. It's all models are useful, but like, they're all wrong. All models
They
are
all
wrong, but
have
some models are
gaps.
useful. Isn't that the quote?
I mean, that's also the things what I view as informatician or data scientists bring to the table to push the word, cancer research community forward. Because if we don't analyze data quality, if we don't evaluate data models, we don't know where are the gaps and how can we advance forward. So,
is there other people that want to ask another question, or I have another one here? Please just like turn on videos or just put up hands. Or Katie, can you let me know if there's somebody else there? I don't want to hog the questions.
I'll keep an eye. Yeah, I think you have the floor for now.
and anybody who knows me, I'll quite happily take it. So if I talk to, we'll say, Paul Nagy and Asya Gulazar and a lot of the people that are quite senior in kind of the development of cancer within OMOP, the first thing Asya will always say is we shouldn't be doing, you know, minimal data sets at all. And of course, like the M in M code is kind of this minimal ideas, that these minimal models. What's your take on that? Their thing is we should map. If you talk to Paul Nagy, he will say we should map everything, you know, onto OMOP, because we don't know what question we're going to want to ask of the data, you know, what side effects or adverse effects or comorbidities we want to model. So there's, and I think that's very much the epidemiologist view on it, you know, that we want everything.
Yeah.
What's your take on this idea? Is it a case of quality has to be sacrificed in order to have the minimal data model, or is it that, you know, we should just try and get everything?
I always have a little bit different opinion than Paul. So my take is more related to we need to manage the knowledge related to mapping, related to data quality, those type of things. I generally don't believe one standard data sets for all projects. I promote the concept called late normalization. Basically, you can derive fit for purpose data sets on the fly if your normalization standardization procedure pipelines to be shared, comment, and as a library there for people to adjust to their study. So you will always see your research questions. Some of the data elements may not be in the standardized data sets. They may be somewhere else actually, and you needed to hand down to find it. So I take the middle way is that I don't believe generalized standard data sets available for all studies, because every study will need something which is not captured currently. And how to move forward is, engage the researchers and identify what are the things which are available in current, what are the things that you actually need to trace back. And those knowledge about how to get such information, that can be a knowledge and shared across the OMOP community, and this will help us moving the field forward to use the data. No, so I don't believe you can have a data set map everything, because map everything. You need. I mean, when we develop standards, we always have something called 20-80 rules. You only probably capture 80% of the frequent concepts. There are 20% long tail. You are struggle, to map. That map quality may also be an issue. Also, standards comes through consensus use, not it's always have that long tail issue.
Liwei, you brought up this slide here. Did you have a comment specifically on it?
Oh, no, actually, it's because the first question is about this. Your question is about this, so I bring this up. So actually, about your last question, Hongfang just commented. I think that's also the value of the community. So, each one in the community has different, study purpose, objectives, and they have different maybe a set of data set preparation methods. I think the sharing within the community is value to improve, to push forward the development of OMOP CDM, I think.
Cool. I wonder, is this, so when I was listening to both, I suppose, your last slide and then looking at this slide, is it a case that, for anybody that does an ETL process, will then run kind of the data quality dashboard on it. You know, you'll have an ETL process. You'll have gone through a process where you do an ETL or carrot or whatever. I know, I think David and Jeremiah are like some of the students that are doing this actively at the moment in our lab, at least. You know, you'll do the different steps. You'll get a data quality dashboard. You'll look at it. You'll go back. You'll refine, and you do this iterative process. Do you think that's something we need to publish, like with the metadata catalog of the data, so that we have that? And I noticed that Michael Caneen is on the call, and he's involved in the Health Information Quality Authority here, and I know they're thinking a lot about data quality as well. If he wants to come in on this, I'm not saying you have to, Michael, just in case you want to.
Before his comments, I want to insert something related to data quality. I know people always say, you know, this data is bad quality, so we cannot use it. My take is that for the real world data, there is no good quality or bad quality. If the things are not standardized, not usable, that's the way how you can improve the patient care through better data capture. Because if this come from practice, if the data quality not well, imagine how the patient care will suffer. So this is, you know, study data quality is a big contribution to the field.
Yeah, I think the data quality, so the CDM OMOP database is a starting point for a lot of downstream studies. So that's why data quality matters. And so I think in our future direction part, we also recommend to share all the mapping, you know, the mappings or the value data set, so that different set can learn from each other. I think that's a good way to improve this, you know, gap.
David has a question there. Liwei, are you sharing the slides there? If you want to, if we don't want to use the slides, Joe, just want to bring it down so we can just encourage discussion.
Just stop share anyway.
Okay.
Yeah, David, you had a question?
Yeah, hi, Yang. Sorry, I was going to ask, like, it seems the M code, based on my knowledge, it seems it's better represent like solid tumor. I know, like, the idea is to be able to at least maybe a minimal data like element that captures like all maybe cancer, like oncology research. But I feel probably based on my at least little knowledge, like probably it captures more of the solid tumor like cancers. So I was going to ask, do you feel there should be like a minimal data like element for blood cancer specifically? Because my project is basically on AML, so I'm like at least trying to see if maybe based on your expertise, based on your research, if there is like a minimal data like an element presentation for blood cancer that stands alone.
Yeah, I think, you know, any effort to push data elements, common data elements definition, standardization would be great contribution to the community. If you see a gap, that's how we can help. I think for MCODE, they're part of the FHIR profile resources, FHIR allow extension. So ideally, you know, you propose this and work with the HL7 FHIR community and the MCODE community to push that towards the standardization, so more people, more consortium adopted.
David, I can send you on those links. Abhishek has been part of those discussions, at least with the European group. I can copy you in on those. I don't think you've been involved in them, David. Would you be interested?
Fine. Definitely, please.
Yeah, I can send them on. I can send on the link to you, so that you can get involved in that, because they're at the moment, I think there's a plan to kind of have a launch of it kind of in Rotterdam, but at the moment it's open. In fact, I'll put up the links there of it, because they have kind of a number of outstanding issues that they're trying to resolve. I forwarded it to a few people this morning. And there's a space. I don't know if this is open to everybody at the moment, but I think that the pages are open. So David here. So you can actually see that there's a number of outstanding issues, particularly when it comes to representing of different types of therapy. So exactly, where hormone therapy or where immunotherapy goes within these models, because they have different schedules.
Yeah.
And so then when you get into the details of this, it's kind of how do you do the scheduling and how is this represented in the model is some of the side of things that, really you probably need the clinical experts to come in and maybe that's one thing that within the eHealth Hub, we can actually bring our clinical colleagues into those discussions and maybe improve those models. It is something that we could take on if there's enough community interest.
Thank you. Then, yeah, secondly, I was going to ask, I was just like very curious on like the study and like inclusion criteria for like the papers that were selected. You mentioned 2010 to 2023. So was there any like reason behind selecting papers from 2010 to 2023? Because what I'm asking is I'm also like trying to I'm also like conducting like a scoping review, and I'm actually considering from 2014. My reason is because the OHDSI like community they started like the first stuff in 2014. So I'm just trying to understand, was there any like reason behind like choosing papers from 2010, since the main focus of like the scoping review was behind like the OMOP and common data model?
Anyway, so this is a question for you. So the publications we select is from 2010 forward. What's the specific reason behind that, and why not 2014 forward?
Because I checked the OHDSI stat. I think that's from 2010. The OMOP was started. OHDSI OMOP. Yeah, I think that's the year. We did some investigation. We don't want to miss any publications, so we started from
Do
2010.
you
Yeah.
see any publication? I think the results actually show it's 2017, 2018, we started to see papers on the OMOP CDMs. Yeah.
Oh, that's for cancer domain.
Yeah.
So the 2010 is the overall OHDSI OMOP.
Yeah.
But we identified the first publication from 2017 in cancer domain.
Okay, thank you. That makes sense. Thank you very much.
Yeah.
Cornelia, time, Marina, just in there for the last question.
Yeah, hi, hello. Thanks for the presentation. Did you find any common theme, like any kind of data that people found particularly difficult to map to the OMOP CDM?
So the mapping, I think for OMOP CDMs, at least in our experience is that in a lot of like genetic testing, those are not well captured in OMOP CDMs. And basically those sequencing and genetics variants, those things are not there much well. But anyway, do you see others for the mapping part?
Imaging data, that was focus of the infrastructure data right now. Imaging genetic are also the major focus by infrastructure right now. But if you want to ask what is not mapped, or do you want to, what's your question again? Sorry.
So basically the domain which have the most challenge of coverage of concepts and the mapping quality, those type of things.
Yeah, I think imaging genetic data may be the things.
I think those are
What was
generally
it?
more difficult, and they've probably only been the OMOP oncology genomics extension is really recent, isn't it?
Yeah.
Yeah.
Is there a US database of ETL scripts or ETL mappings?
Yeah,
Or
so
can
there
you
is,
infer it from your analysis?
so in the analysis, we don't have it, but I know from the common data models, we have a big market on Epic. So from Epic, their data warehouse like Clarity or Kabudo, they do have the shared scripts to map to OMOP CDMs. So then you have other common data model like a Picori, PicoNet model, I2B2 model mapped to OMOP CDM. So those are the common things we generally see as shared. But even that, we also notice that we do need to really check the mapping, check the quality due to the local implementation or local practice of the documentation. They may not follow standard. So we don't have standardized practice, so it's a challenge to standardize ETL. So.
Sorry, Katie, I think we're nearly at time, aren't we?
I think we are. Thanks very much. There's some details for upcoming OHDSI meetings in the agenda. They've also been emailed out to the mailing list as well. So I think that was it from my end anyway.
I think if anybody isn't part of the mailing list and wants to join it as well, just contact ehealth@uol.ie. Is that the easiest way, or look at the website?
Okay.
Maybe you'll put it on the
Yeah,
chat.
they'll find us.
Okay.
Yeah.
Thanks,
Thank you.
everybody. Thanks so much for
Thank you
joining
so
us
much.
today. Okay.
Thank you
you
for
all.
having us. It's a
Thank
great
you.
conversation. Bye-bye.
Bye-bye.
Thank you. Okay, bye.
Bye.
Thanks.
Thanks, bye.
Have a lovely weekend.